Hello, welcome to the stream. I'm Jared. I write Ruby code. I do e-commerce things. A company called Supergood. We use a Ruby on Rails based e-commerce platform called Solidus. That's not what we're doing tonight. Not doing anything to do with that. Instead, we're doing Advent of Code puzzles, Christmas themed programming problems. The 8th day of the Advent of Code is about to go live in about 1 minute and 15 seconds, and we're going to try to attempt it. We've so far been relatively successful at all the previous days. Yesterday we were arranging crabs. We got to recall, I think that's high school math, our sum of consecutive integers formula. I couldn't remember it, but I remember that there was one, and I don't think looking that up is cheating. Though I did actually go back afterwards and write a solution that I would have written had I not known that there was a formula for doing it. So that was just for fun. Did that after the stream. Today, just hoping it can be a quick one. Got a big day tomorrow. Among other things, new Warzone map. I think that's coming up tomorrow. At least if you got the Vanguard, and I played a bit of Vanguard. I love that I have transitions now. All right, let's do this thing. Don't be afraid to help me, chat. 7 segment search. Ooh, now it looks like we're getting into some fun data modeling, fun stuff. Here, let's go. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Sensors indicate another exit to this cave at a much greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays in your submarine are malfunctioning. They must have been damaged during the escape. You'd be in a lot of trouble without them, so you'd better figure out what's wrong. Each digit of a 7-segment display is rendered by turning on or off any of the segments named A through G. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that makes sense to me. So to render 1, only segments C and F, etc., etc. Yes, I understand. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output on signal wires A through G, but those wires are connected to segments randomly. Worse, the wire segment connections are mixed up separately for each 4-digit display. All the digits within a display use the same connections though. Okay. So you might know that only signal wires B and G are turned on, but what that doesn't mean that doesn't mean segments B and G are turned on. The only digit that uses 2 segments is 1, so it must mean segments C and F are meant to be on. With just that information, you still can't tell which wire BG goes to which segment. For that, you'll need to collect more information. For each display, you watch the changing signals for a while. Make a note of all 10 unique signal patterns you see, then write down a single 4-digit output value, your puzzle input. Using the signal patterns, you should be able to work out which pattern corresponds to which digit. For example, here's what you see in a single entry in your notes. Okay. What's that? Oh, I see. Okay, sure, got it. It's just a line wrap. Each entry consists of 10 unique signals. Oh, sorry, never mind. A pipe delimiter, and finally the 4-digit output value. I'm not sure I understand, but I'll press on and I'll come back. Within an entry, the same wire segment connections are used, but you don't know what the connections actually are. The unique signal patterns correspond to the 10 different ways the submarine tries to render a digit using the current wire segment connections. Because 7 is the only digit that uses 3 segments, DAB in the above example, means that to render 7 signal lines, D, A, and B are on. Because 4 is the only digit that uses 4 segments, EAFB means that to render a 4, signal lines E, A, F, and B are on. Using this information, you should be able to work out which combination of signal wires corresponds to each of the 10 digits. then you can decode the 4-digit output value. Unfortunately, in the above example, all of the digits in the output value, C, D, F, E, B, use 5 segments and are more difficult to deduce. For now, focus on the easy digits. Consider the larger example. Because the digits 1, 4, 7, and 8 each use a unique number of segments, you should be able to tell which combination of signals corresponds to those digits. Counting only digits in the output value, the part after the pipe on each line. In the above example, there are 26 instances of digits that use a unique number of segments, highlighted above. In the output value, how many times do the digits 1, 4, 7, and 8 appear? Oh, there's a lot to unpack on this one. We picked a hard one today. This is a test input, so let's at least do a little bit of work so we know for this test input. I believe you said those would be all in one line in the puzzle input, right? Yeah. So this is the digits 0 through 1, and this is the output number, and we don't know, like we know FG is a 1, and I think we established 4 digits means it's a 4, and 3 digits means it's a 7, but there are a bunch that are 5 or 6 digits, which are difficult. My Windows is off center. There we go. There we go. So we're just looking for how many occurrences of the easy digits there are in the output numbers. So we're just, okay. Seems I'm editing the wrong file here. I got here, did I just delete what was already there? That's funny. All right, day 8, part 1 spec. Let's turn our brains on here. It's supposed to equal 26. So we receive an input. We need to parse this input. I mean, we only care about the 4-digit ones, right? So the outputs is input, split it on the pipe thing, or sorry, split it into lines first. Then map that to the last, because that'll pretty much 2-element arrays. We just want the last ones, and then we'll map those through output, and we'll break that into words. I think that'll give us a basis, and then we can just flat map this because we don't actually care about anything to do with these. We just want to know how many times those digits appear at all. I'm just gonna pry. Just put that. Just skip this back. Undefined method split. What am I calling split? So I'm meaning to map these lines and do line.split here. And since we're already mapping, we might as well call that last here. Okay. So this gives us all our output digits. We just want to count the number of digits where it's so 1, 2, sorry, no, it's 2, 3, 4, or what digits are we counting? 1s are 2 digits, 4s are 4 digits, 7s are 3 digits, and 8s are 7 digits, right? Yeah. Yep. That produces the right output. Double check it. Okay, part 1. Test our answer. Cool. All right. That was relatively easy, but I can imagine part 2 could be significantly harder. Very quiet, chat. Are you having a nice day, chat? Hello. I did hear some people earlier. Hopefully my music's up loud enough that you can't hear people in the hallways too much. Nobody's walked right by. And the dog is asleep on the couch. Surprised she's not asleep behind me, actually. There's like a dog bed right behind me here. Usually she comes in here with me. All right, part 2. Through a little deduction, you should now be able to determine the remaining digits. Consider again the first example above. After some careful analysis, the mapping between signal wires and segments only makes sense in the following configuration. Sure. So the signal patterns would correspond to the following digits. Sure, I believe you that you could deduce that. Then the 4 digits of the output value can be decoded. Therefore, the output value for the entry is 5353. Following the same process for each entry in the second larger example above, you can figure it out. Adding all the output values in this larger example produces 6,121. What do you get if you add up all the output values? Okay. How do I want to do this? Part 2 spec. So we're expecting a value of 6,000. We don't want to skip this anymore. We want to keep running it. We want to take our input from above. And we can kind of refactor this. We don't know. I do like code sharing between the examples just to, I don't know, make this harder for myself. So that's why I always inherit from part one. This is a kind of a neat one. Maybe I'll try and do that after. I know there's some coaching that could happen, but I'm not going to get ahead of myself. Okay. So we no longer want the last. We want actually, and we don't want a flat map anymore because we want, I'm gonna make a new class called an output. It's going to take a signals digits, I guess, maybe. That way it's getting pretty hard to read here. And then outputs. Also, I'll talk through this in a sec. So we'll just map these to integers and sum them. Okay. I'm just working on the parsing, and then I'll talk through what I'm going to do with that output class. So this is going to be the two arrays. I'm not liking my naming here, but that's fine. Signals, I think. That's fine. That's not horrible. Cool. So that works. Can you get some errors? Can implement 2i. Then at least we can get a wrong answer out of this. Oh, my debugger's still in there. Cool. Then I figure we just change this number until we get the right answer, right? It's gotta be bigger than that one. So there's 100 of them. Oh, that's not a multiple. Yeah, somewhere around 10. Oh, we overshot it. Oh, I see. I'm not actually gonna do this. That'd be funny though. It's what, 600 divided by 100, 61. So if I put that in there, I just get the right answer for my tests, and I've solved it, right? Oops. Should in the wrong spot. Perfect. Ship it. Okay. Sadly, we're actually gonna have to do something here. So we can infer. I think we want to break this puzzle down a little bit. We want to take one of these. And construct one. that. We'll do let put this, and then we can use Ruby's handy word syntax for arrays of words, and now we have something to work with. And we can, our example should give us for this, maybe we should use this example. So let's just use the other example rather than this one. I guess I could use that too, but this one's worked out, so it'll be easier to debug. Kind of just deferring, actually thinking about what I have to do here. It's agile software development, deferring solving this problem. So we should be able to. Did I skip this one? Let's just focus this back here, and fix my typo too. Cool. So turns out just hard coding a number wasn't the right solution. Dang. So we have a bunch of signals, a bunch of digits. Need to figure out the mapping. Okay, let's just put the 7-segment display in my code to look at. In fact, we could take this whole thing. How do I host my websites? I mean, it depends on the kind of website. I host some things on Heroku, host some things on AWS, I use Netlify for some things. Really depends on what kind of site it is. Personal one's on Netlify. It's just a Gatsby application. Gatsby project, I don't know if you want to call it an application. Why'd you ask? Netlify is really nice. It's free hosting for simple stuff. Good for hosting static stuff. I think I actually even have or used to have anyway, a Netlify site that was sort of a resume site that I built out. Okay. So should be able to do something here. So we've got A to G. This is ugly, but let's just humor me. A to G here. When we begin, without any work, what do we do here? So if we look at the 2-digit one, we can figure out, we can almost narrow this down. This is actually a tricky one, unless I'm missing something obvious. There's too many ways to, we can't just try all the possibilities on this, it would be too slow. So what, like 7 factorial? Whatever that is, too big. Okay. So what are we trying to figure out? We're trying to figure out which all right, brain. So the 2-digit one. So my thought was we'd try and narrow down which ones could be which, but so the issue is the 5s and there's only, wait, how many? Okay, wait a second here. Okay, so if we know which one the 1 is, in this case the 1 is AB, it means that A and B are C and F or F and C, and that means we can look at the 6 and the 9, which are the two that have 6 cells visible, and the one that shares 2 digits with the 1 is the 9, and the other one is the 6. Oh, no, there's a 0 too. But regardless, that tells us which one the 6 is. And it tells us which one of the... Okay, let's maybe group these so that it's a little easier to read here. Just a lot of information here. Let's just pull this off here. Oh, quite making room there. So So that's that one. And then we know, let's just move the ones that we currently like just know onto their own. So the one, we know, 2 and 3 we don't know, 4 we know, and 7 and 8 we know. So we are trying to distinguish 2, 3, and 5. Okay, that gets us a little clarity anyway. Just gonna close this one. Oh. Okay. So 1 allows us to figure out which one is 6. One also tells us which input is A. That doesn't help us with anything because all of the ones we need to figure out are A. But figuring out 6 figures out which one of C and F is, or which one C is, which allows us to figure out which one 5 is. Which tells us which one E is. Which tells us which one 2 is. And thus 3. And 9. And thus 0. Okay. God. I have to remember whatever it is that I just said. So I'm a TDD guy. I'm not smart enough for this stuff. All right. Okay. So let's do it. Let's figure this out. So where do we start? We know 1 tells us which one 6 is, right? So we need to so let's say 1 is equals or 1 is signals find. I'm not typing all of that out. S.length is 2. Let's just get in there. So you know that 1 is AB. So at this point we know from signals, I guess we have it here, of the 6-digit ones. So signals filter. We know the second one is a 6. because it doesn't have both A and B in it. Right? And follow that one. We know one of these is A and one of these is B. 6 doesn't have one of them. The other two have both of them. I'm going to split the signals. Map them into just arrays of strings because it's easier to figure this one out this way. I don't really know how the string operations do this. But let's go with what we know here. We know 1, 7 is the one that is 3, 8 is the one that's 7, and 4 is the one that's 4. Cool, so we've got the digits we know. And we know that 6 equals signals, find signal where the intersection of 1 and it has a length of 1 and that its length is 6. Come on, brain, we can do it. All right, let's see if that works. T, D, F, G, E, B. Yes, that is what we wanted. Okay, we know what 6 is now. From 6, we determine 3. Because 6 will, or is that how we do it? What do we do again? That tells us what? Oh no, we use the F signal. So now we know that the C is whatever that intersection of 1 and S is. So we can figure out 5 is the signal that there's probably a much better way to do this. I'm sure there's some smart person strategy for this, but we're just gonna think really hard and encode our thinking into the code. So signals find S, where S length is 5 and S includes C. No, doesn't include. We're not S includes C. 2 of them will include C. All right. And that's that. Does this work? S. This is 6. Did we find something? G, C, D, F, A, is that right? G, C, D, F, A is 2. Well, that's unfortunate. Is the other stuff we're doing right? 8. Is my thinking just totally wrong? A, C, E, D, G, F, B. Or 8, of course 8's gonna be right. 6 is the one I want to test. C, D, F, G, E, B. C, okay, so that's right. So what's wrong with my thinking here? Did I do this backwards or something? Oh, I did. I think I did this backwards. So the thing that 1 and 6 have in common is not C, it's F. I figured out F. We can do this lazy. So that means C. I can do that. What did I see? Oh, and this is supposed to be C. Ooh. CDFBE. CDF. Okay. Yeah. Right. Okay. Cool. Good. Good that we can check these as we go. All right. Brain power again. So now we figured out 5. And we know C and F now. So I guess we can just figure out 3 and 2 now, right? Because, yeah. Because 3 is... so let's find S dot length equals, so it's 5 length 1 and 1 ampersand S dot length is going to equal 2. Seems right. FBCAD. Yep. So that working works. That thinking works. And then 2 is equal to signals. Find S dot length is 5 and 3, 5. So just it's not 3 or 5. GCDFA. Cool. All right, so it works. Whew. All right. So now we have can't scroll. No mouse support here. 1. This is actually kind of fun. 1, 4, 7, 8, 6, 3, 5. So we need to figure out zero and 9. And I guess we can just do this with overlap. I might have been thinking too hard about these. What's the easiest way to do this? I mean, we can figure out which one. We just use 4 to figure out which one is 9. What's the easiest? What's the easiest solution? So 0 equals signals find s dot length equals 6 and s does not equal 6 and s dot let's just do another union with 4 and then 9 is equal to signals find s dot length and it's not 0 or 6. Seems right. CAG EDB. Yeah. I'd be surprised if we somehow got 9. CEF ABD. CEF ABD. Yeah, okay, we got them all. Output. So we just need to take now we just need to take our digits, transform them into the numbers. And then 2i it. This used to be output 2i. And we're actually gonna be able to reuse this for our part 1, I guess, if we wanted to. I don't think I'm gonna do that. I think I'm gonna go to bed, but hypothetically we could reuse this anyway. So this is digits, map, digit, and then join those, and in here we'll do case D when 1 then 1. I don't know how many that is. This is one of the sillier things that I've ever written in Ruby. I can think of ways to structure this better. But I'm not going to do that. I'm just going to solve the problem. If I get bored tomorrow and need something to hack on, maybe I'll come back and refactor this. We'll see. Cool. I forgot how to write code. Cool. Got 0. That's intriguing. Oh, right. So this is mapping them to the digits. Then we join. What is happening? Why am I getting? What have I done wrong? Output. It's an empty string. Okay. Digits is the digits. What's wrong? All right, so we've got digits. We've got 1, 2, 3. Oh, the order's not the same. That's cool. We have set operations in this language, so we are fine. Love sets. Does that fix it? No. Why does that not fix it? The digits are all no sets. How am I? Yeah. Whoops, that's not the right command. All right, let's see. Let's see what we got in here. D is a set containing CDFAE. 1 is a set containing AB. 2 is a set. 3, 4. So this is going to be that one. Well, let's learn something new today. Set Ruby. How does set triple equals work? Aha. That is not useful to us. Not at all. Okay, well, so just for clarification here, case statements, which are kind of like switch statements in Ruby, sort of Ruby's version of switch statements, they use triple equals for the when conditions, which is frequently very useful, but it's not useful here. Because I guess sets compare use triple equals for set membership. So we want to do this, and we're going to do a macro. Vim macro time. Cool. It ain't pretty, but it might work. It does work. All right, now we can back things up and see if that makes our broader specs pass. It does. Thank you, Jay Hawthorne. Yes, I do love a good Vim macro. Bin solve part 2 gives us a number. Hope it's the right number, because this is going to be hell to debug if I did something stupid. Yes. All right. That was fun. I enjoyed that. I vaguely. We got 7 minutes before it was an hour. Let's do the refactoring. It's real quick here. So I'm just gonna commit that. Make day 8 part 2. Get that done. All right. So without changing any specs. Oh, well, that makes me feel nice. Glad to hear. I guess. I wasn't feeling good about this solution, but I was considering extracting all these out to methods, memoirs, and then I was like, nah, I'm not gonna do that. All right, so let's bring up day 8, part 1, and let's make them both use this class just for fun. We don't need to, but so we can put that in there. Delete our big comment. That was for learning purposes, and it's preserved in Git history anyway. So that should still pass. Oh, that should still pass our tests. Cool. That's to be expected. I'm gonna just expose a digits method here that returns output.split. I'm going to reuse, take this constructor, move it over here, and then we're going to output dot what was I doing? Oh, right. This is so output dot digits. So we're just counting the occurrences. So we can flat map our outputs to their digits, and then there'll be literal digits now. So let's just go back to the puzzle. And we just want those 4 digits. They'll be strings though, so let's does that work? Did I use my brain good there? Was that the solution I got before? So long ago. Who knows? Okay, does it show me the solution in the UI? Oh yeah, it does. Okay, cool. Yeah, that works. Cool. Amazing. Cool. So now they use the same output thing and just have slightly different solution pieces. Whoops, did I do that wrong? No, that's right. We're good. All right, it's been a pleasure, but that's enough of that kind of code. I'll be back tomorrow night, though I'll have been playing Call of Duty, so I've already used my brain power trying to figure out the new map, I'm sure. But it's been fun. Thank you, Jay Hawthorne. Thank you, Megathumbs. Thank you, Sugboat. Thank you, anyone else in the chat who didn't say anything. Look forward to being back tomorrow night. Then I'll be taking 2 nights off for hockey one night and a staff party the other, so should be fun. But I'll be back Saturday. Thanks, everyone.